Assalamu alaikum. Let's continue our class from where we left yesterday. So we studied up until condensation polymerization, and we'll be doing a couple of examples from today. So let's see how such polymers could be formed actually. So forming terylene is our first example, which is polyester. So oftentimes you will see the name being coming polyester, or polyester cloths. So that's actually basically the form is polyester. So that ester is being like made from the monomers. We can actually see what is it. It's an ester, isn't it? Like the name suggests, this is actually ester. So the monomer should be what? Carboxylic acid and alcohol. But since it's a polymer, that means not only acid and like carboxylic acid and alcohol should be like just fine. Rather, it should be diol and dicarboxylic acid. Why? Because we need to form a chain reaction. Dicarboxylic acid. Okay, so let's see. In this case, our diol should be this CH2, CH2, OH, here OH, okay? And our dicarboxylic acid should be the benzene ring, okay? And we have carboxylic acid here, as well as another carboxylic acid here. Got it? Now, let's see. So oftentimes you would see actually another carboxylic acid could be HOOC, CH2, CH2, COOH. Okay, this could also be there, like present, or that's a CH2. Like this CH2 group could be there like 4 times, or simply let's write it in like just CH2, CH2, 2. That means CH2 actually we are having 4 CH2 here. So oftentimes you will see in that manner also some molecules, but let's not get to that part. But let's see how this like reaction happens. So the reaction tends to be in this way. So let's say we have n number of our alcohol, which is HOCH2, CH2, OH, and we have n number of carboxylic acid, dicarboxylic acid to be more specific. And here benzene is our central molecule, like central structure in the carboxylic acid there. When they react, they tend to form our n number of such products. So we have, let's say, CH2, CH2. Then we have O, C, O. We have our benzene. And we have a C double bond over here. Okay. And we have our one of the alcohol here. Yeah, oxygen here. So that's basically what is happening. And wait a minute. Is this the case? No, that should be this way. Yeah, so this is the case. So that means we have here, this as a repeating unit, this will repeat n number of times. At the same time, we will be having what, 2n minus 1 water. So this is actually condensation polymerization. The water is being formed. Now, if this polyester, like if let's say like whatever, this is actually an ester linkage, isn't it? So that means the total linkage, the chain will be a polyester. Many number of like many ester linkages there. Now, if we want a softer polyester, okay, let's say a very soft polyester is wanted, then what should we do? Then the number of carbon should be increased in between. What does that mean? That means here in between whatever we have, if we increase it to, let's say here we have what, CH2, CH2. So instead of CH2, CH2, let's say if we press CH2, let's say 20 times. And instead of this, if we press, let's say some other, let's say, CH2 30 times. Okay, that means what? We have now longer carbon chain, yeah, before forming our this ester linkage, yeah. That's what causing it to be soft, tender, because now less bond is there, like less strengthening like component is there. So if like think it like this way, if like when you have like let's say when you have a plastic material which is like shorter, think about that, and of the same thing with very long, like very tall or very long, what happens? It tends to like wiggle, or it tends to like you can bend it from like from the middle. However, if it's shorter, it's difficult for you to like bend. That means like it becomes, for like with larger surface area, it tends to become shorter. And one of the other reason why it becomes softer is like due to the like distance, like due to the increased distance between the bond. Okay, so between like the ester bond, ester linkage, the distance actually increased due to the presence of longer number of carbon atoms. Now let's see some example, like question paper example. Okay, so let's say example 1 is capsaicin. So C18, yeah, C18 H27 NO3. So you need to actually identify what will be each of the molecules, like structural formula. Capsaicin, yeah. So this is, that's our molecule. Now, two portion will be actually, when like before doing that, let's write the condition first. When we boil with H3O plus. Now, what does H3O plus mean? That is equivalent to H plus actually. And H plus means what? Acidic. So writing a hydroxonium ion, remember it's the same thing as being just present H plus, means acidic. So we would get two of such components. One is, in this case, let's say this is actually one of the molecule. This bond with oxygen, then this oxygen is bonded with this CH3, okay? And the other part will form something with a formula of C10H18O2. Okay, now when we make it to undergo, make it to itself to react with, let's say, apply heat with concentrated KMNO4 like in presence of H plus, we should get two such products. One is, in this case, having a formula of C6H10O4. Another, in this case, should be the formula having a formula of C4H8O2. Now, this could be formed from the CH3 to CH2OH. Now, from here, when we apply some condition, this condition is number, before that, okay, this is, let's say, condition number 2. I forgot to give condition number 1, which is in this case, now this condition, like whatever is given as number, we need to write the condition as well. And also we need to find the structural formula of them, only those which, like, whose molecular formula is given, or those who is inside the boxes. Now here, if this molecule, like the previous, like the reactant is C6H8N2, if we apply the condition which is mentioned as number 1, we get this product. Okay, now how do we get actually this reactant? If we make bromine CH2 4 Br to react with, let's say, heat with KCl, then we get this product. Okay. Now our like duty or our task is to find actually what are inside these boxes and what is this condition. Like what are these conditions? So these are the like things you need to find. So let's do this first example together. I might like I should ask you to like try it by yourself. Just pause the video and see if you can understand what is being happening, what is actually happening. And it's nothing to get scared of. It's like actually pretty easy thing. Just like the things, like the molecules are in this case a bit larger than previous examples. Okay. Now see, our first thing is actually what? Let's go from the bottom side because it's difficult for us to actually directly find this one. Okay. So oftentimes we should do what? Bottom up approach. So that means starting from bottom, we will go upwards. Let's see, what are we like, what informations are we given? This is what this is given as, let's say this is the structure which is, this is the structure we are been given with, yeah. And the other one is we have CH3, CH3, we have CH, OH, okay. That's what we are given with, like we're provided with. Now, let's see. Let's try to solve. From here, they're applying heat with KCl. Remember what reaction is happening? This is actually like nucleophilic substitution reaction is like taking place with this condition. Remember from like the AS content, which is like the characteristic reaction of halogen alkane. So that means from here, bromine will be disappearing and we will be left with actually CH2, 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 and Br. Sorry, instead of Br, we'll be left with Cn and Cn. That means this will be gone. Cn, Cn will be there. Now let's see if the molecular formula like is fine. We have 1, 2, 3, 4, 5, 6 carbon in total. So 6 carbon. Hydrogen, how much? 2, 4, 6, 8 hydrogen and 2 nitrogen. Okay, so that's done. This is actually this molecule. This molecule is this one. Okay, now let's do some other where, let's see, we have actually CH3, CH, CH2, CH, CH2, COH. That is this molecule. From here, let's see how many carbons we have so far. We have here 1, 2, 3, 4 carbons, and here also 4 carbons. That carbon number didn't change. How many hydrogen do we have? 3 hydrogen, 3 hydrogen, 6, 7, 8, 8 hydrogen, 9, 10, 10 hydrogen total. So that means 10 hydrogen should be there, but here we have 8 hydrogens. That means 2 hydrogen disappeared. And the option, like another thing is we have we have in this case 2 oxygen. Now what could be what can be a possible solution? Now one of the possible solution is what we can think is whenever carboxylic acid is formed, okay, whenever the primary alcohol oxidizes to undergo like oxidation reaction in order to form carboxylic acid, like, or whenever oxidation happens, what happens? Whenever oxidation happens, 2 oxygen is possible to form. Like only when alcohol is undergo oxidation reaction, is made to undergo oxidation reaction, carboxylic acid is formed where there is the presence of 2 oxygen group. Then let's try to draw it. When after oxidation, this undergoes, so CH3, this is 2CH, and we have carboxylic acid COOH. Let's see now how many of each we have. So there we have 2 carbons, because we have like this whole as a 2. So that means 2 carbons, 3, 4, 4 carbons total, fine. Here we have 3 carbon, that means 2, 3 is 6, and we have 7, 8 hydrogen. 7, 8 hydrogen. So, and we are left with 2 oxygen. That means this sort of satisfies the like this molecule. So this is actually this molecule. And what should be the conditions? Our conditions should be, in this case, K2Cr2O7. That means number 2 should be this one, K2Cr2O7, with, we can say, heat under reflux. Remember, not, it shouldn't be heat not under reflux. Okay, why? Because if it not under reflux is given, then aldehyde will be produced, and aldehyde, in aldehyde there is like no double oxygen, there is only single oxygen there. Reflux. Okay, now this is like fine so far. Let's see what else can we form. Here we have C6H10O2. Okay, now from the C6H10O2, what can we observe? This, like, if this is made to go under certain reaction to form that, like this molecule, there's no presence of nitrogen. That means nitrogen disappeared. Nitrogen disappeared. What can then it be? Remember, often like previous examples we did, like the examples we did beforehand, like before coming into like polymerization, we did a couple of examples, isn't it? So there you'd see in many examples we have cyanide present, or carbonyl compounds were there, and when we made them to undergo H plus, okay, H plus, and heat under reflux, or heat under reflux, okay, REFLUX, when we made it to go under this reaction, what it did was, like, it what was the reaction name again? That actually underwent, just a minute, let me see it and tell. Most probably that was, obviously that was oxidation reaction, but was it hydrolysis? Let me just see and say. Carbonyl compounds, where do I have them? Sorry, not carbonyl, nitrile compounds. So when nitriles are so yeah, that's actually hydrolysis of nitrile compound. So whenever, like, this is actually hydrolysis of nitrile compound in presence of H plus aqueous. So that means acidic hydrolysis is happening. When that happens, I mean, sorry, like this react, like this condition, when this happens, the nitrogen disappears, okay, forming like amines or something. But carboxylic acid didn't form in this place. So COOH happens here, and this remains same. And again, this COOH, like instead of N, we have COOH. Let's see if it matches or not. There should be 1, 2, 3, 4, 4 CH2. CH2 should be 4 here. If it matches, let's see. So we have 4 carbon here, 5, 6, 6 carbon here, 6 carbon is there. We have 4 to the 8 hydrogen, 9, 10, 10 hydrogen, and we have 1, 2, 3, 4. 4 oxygen is there. Nice. So this is actually the like product. So this should be COOH, CH2, 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 and COOH. Okay, and the condition should be H plus aqueous heat under reflux. So this product is going to be this bottom one, this one. Okay, so this is our product, and now let's see what is happening in this over here. Here we can see when heat with concentrated camphor is applied, these two products are formed. Now what are these products we found? We just found these are like carboxylic acids. Both are carboxylic acids. So this is one of the molecule, this is one of the molecule which is formed when this reaction takes place. I mean, this condition reaction takes place. If you go back to like, AS contents, you'd see that we like when they're okay. Before observing that, let's see one thing. How many oxygen is there? 2 oxygen. But these two products have how many oxygen? Each has here 2, here 2, and here 2. That means 6 oxygen. That means like oxygen number actually was like less there. How could that be possible? One possibility is, if you like, as I mentioned, if you go back to this context, you'd see whenever there is like carbon-carbon double bond, like in terms of alkene, there were some certain conditions. If hydrogen are like, if that is present there, whatever the other thing is, and if let's say hydrogen and let's say R and R, like either of them are present, like if this is present or this group is present or this group is present, what happens? Let's see. So if HH is present, then when that condition is applied, the K2Cr2, like oxidation reaction, this is actually what is happening here is oxidation reaction. These conditions are condition for oxidation reaction. Now, when that conditions are applied in this any of this molecule, what happens? If the carbon containing double bond, the carbon containing that double bond is bonded with 2 hydrogen, that will form carbon dioxide. This will break and form carbon dioxide. However, if the carbon containing double bond, like the carbon which contains this double bond, is like having bond with a hydrogen and an alkyl group, it will form a carboxylic acid. So C, this R will remain same, this H will remain same, and here C, I mean, here we will have yeah, COOH, yes. So this will be the scenario. And just a minute, let me see where we have. Did I do it right? Okay, so sorry, this shouldn't be the case. Actually, the hydrogen will disappear in this case. Yeah, that will make sense. So we have COOH. So yeah, that defines the number of bonds. So this will be formed if this is the case. However, if both are R, then that reaction will cause to form simply ketone. That means R, C, R, double bond O. Okay. Now, why is this case? Because the reason is due to the presence of hydrogen. Like if hydrogen is present, hydrogen is very weak. Like hydrogen carbon bond is very weak. That could be easily broken to form some other molecule. But in this case, see this carbon, central carbon, the double bond containing carbon does not have any hydrogen with it. That means no hydrogen could be broken. That's why it will simply form this like ketone here. Now our like observation is from here, what can be one possible solution? Our two of the reactants are, let me draw with a different color. Our two products are these, like this one and this one, isn't it? So how could the reactant coincide with like such double bonds? One possibility is carboxylic, like the carboxylic acids part. Let's see. So if we redraw these structures here, so CH3, 2CH, COOH, and we have COOH, CH2, 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 and COOH. Let's do some reverse engineering. If this is the carbon, let's say, which had the double bond, okay, then it had a possibility that maybe it had like a hydrogen with it. That means if this is the carbon and this is the other part, which is this one, CH, this one. Okay, so let's say CH, CH3, 2. This is the other part, the alkyl group. And since there is this carboxylic acid, that means if it had a hydrogen here and a double bond here, then it would have been possible. If the reaction occurred, then this would have been possible. Okay, fine. That answers that 2 hydrogen is gone, but 2 more hydrogen needs to be gone from the other molecule. Let's consider this one. if this is the carbon, which is like this part is the alkyl group, which is CH2, 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 and COOH. Okay, then there's a possibility that if this hydrogen is present here, it could form actually that carboxylic acid for this molecule as well. That represents, like, that sort of defines how this carboxylic acid should look like. Now let's see if the molecular formula and all the carbon number it matches or not. Our molecular formula is C10H18O2, C10H18O2, C10H18O2. Let's see how many carbons here. Here we have 2 carbon, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon is here. Okay. Then we have, let's see, hydrogen. Here we have 6 hydrogen, because 3 into 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 hydrogen. And we do have 2 oxygen only. There's no other oxygen whatsoever in this molecule anymore. So 2 oxygen, that means this actually defines the condition. So this is actually that molecule, this one. So this one is also found. Now what are we left with is this molecule. Let's see what we have here. Before applying heat with water, we have some molecule with like this number of carbon, this number of hydrogen and nitrogen and oxygen. See the after applying heat with acid, the nitrogenous part came to the left side, and the double bond, like the carboxylic acid with the double bond, came to the towards the right side, one to the left side, one to the right side. Now, what reaction happens when we apply heat with H+? What sort of reaction is this? If you think it clearly, think it wisely, nitrogen is there and carboxylic acid is there, H+ is added. This could be a hydrolysis reaction. Now, hydrolysis reaction of what? Hydrolysis reaction happens for 2 of the situations. One is if there is a ester linkage, if there is this ester group, okay, which is a possibility in this case. If there's ester linkage, that could be broken to form 2 separate molecules. But here we don't have any alcohol. That means ester cannot be found. One possibility is if there was amide. Now, how do I know if there is amide or not? Now, to answer that question, we have a nitrogen here and we have carboxylic acid here. The only possibility that this will react with such a molecule to form carboxylic acid and amine here is that there was a amide group. So this is actually hydrolysis of amide. So if we try to draw it, then the capsaicin should be OH. Remember, this is not alcohol. This is what? This is phenol group. And phenol is acidic. One acid cannot react with another acid. That's why this couldn't actually react with the carboxylic acid. That's why, like I said, this is not possible to form that ester linkage. So this is nitrogen and we have a hydrogen here and forming the amide linkage, and we have a carbon here. The carboxylic acid here was this one. So that means over here, the bond should be formed. So let's say this is the carbon oxygen and all the other particles should be the same. So CH2, 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 and we have this part C, hydrogen, double bond, hydrogen, and here is CH, CH3, 2. Now let's see if the formula matches or not. There is the amide linkage, and hydrolysis of this amide linkage should form these 2 products, like this product and that product, like this nitrogenous product here given. Now here C18H27NO3, C18 H27 NO3. Okay, this was supposed like the required formula. Let's see how many carbons we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Where is another carbon going? Let's see again. We have 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. One of the carbon seems missing. Did I miss something? Let's see. We had so far it was C10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many carbons were there? 1, 2, 3, 4, 5, 6. Oh, there is this another carbon. Yeah, there's this another bend here. I didn't give the bend here, so there should be another bend there. So this is the condition. So that means here is another carbon. That defines actually there is now 18 carbon. Let's cross check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah. So here is actually 2 carbons. So that gives us 18 carbons there. Let's see hydrogen number. This 3 hydrogen, 1, 4, 5, 6, 7. And here should be, if this is C, there should be 2 more hydrogen. 8, 9. Yes, there's 10. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And we have 21 plus 3 to the 6. We have 27. That means 27 hydrogen is also there. We have a nitrogen here, nitrogen. And how many oxygen do we have? 1, 2, 3. 3 oxygen. So that means this is the possible structure. So this is actually the structure for capsaicin. Okay. Now let's go to next example. Let's say we are given a molecule which has this formula C8H15NO3. Now when this is hit with dilute acid, some dilute acid, it tends to form again 2 products. Remember, this sort of question contains huge marks. So organic chemistry, if you can understand, there's high chances you can score like more than 90%. So organic chemistry is the way to go. C4H6O3. And here we have another molecule C4H5NO. From here, when we apply certain condition 1 and condition 2, we get this molecules, or we get this, those molecules. Now, what could be each of them? Let's see. Let's start with, these are given, let's say this is F given here. Then we have, that is F, that is given as G, like the molecule name is G. This molecule is given as J, and this molecule is given as H. Okay. Now, what could be understood from this situation? Let's see. Here we have some molecule F as this H. This is G and this is J. Let's say you need information. Yes, you do need information. Let's say some of the information you are given is F is neutral. Okay. F from F, G, H, J, they all tend to undergo iodoformation test. Iodoform test. Iodoform test, if you go back to AS contest, you'd see there's the proportion iodoform test. Now G is mentioned that it reacts with H2SO4, sulfuric acid, and H reacts with NaOH. So it reacts with NaOH. Okay. These are the information given to you. Now, based on this information, you need to solve this question. Let's see. Just say F is neutral. FGHI iodoform test. G reacts with H2SO4 and H reacts with sodium hydroxide. Let's start with, let's see, what could be, wait, here, do we have NO2 or NO? This is simply NO. My bad, this was NO. So yeah. Then we can start with, I think more information is given towards G, I guess. Let's see. This is H2SO4 iodoform test. In order to have iodoform test, the component should have this part. And since there is oxygen there in G, like either this group should be present in participating iodoformation reaction, either this group should be present, CH3, or if this is an alcohol, then CH3, H, OH, this should be present. Now, what does deep G contains? It says G reacts with H2SO4, sulfuric acid. That means G must contain an amine. That's alkaline. So